Well, it was like a weird time, like 47:23, so I don't know. I didn't check the other one to see if it was like the exact same, but yeah, but it could have been a time thing, but it didn't like stop right at an hour. Okay, so -2 plus 3 plus 1, so 2. And then we need normal dot normal. So 4 plus 9 plus 1, 14. So 2 over 14 times normal. So we projected, oh, here? Oh, yeah. Thank you. Thank you. Oh, yeah, what was I doing? Okay. Thank you. Yes, catch my mistakes before I end up using this vector for other things. So to recap, what we just did was projected AB, this vector, over onto here. So we found the portion of the normal that's the right length, right between A and P. So it's between A and P. Now we want to find the length of that. So we were looking for the distance. So again, they're all over 7, right? Common denominator, so we can actually pull that 1 over 7 out to the front. So 1 over 7, and we're left with the square root of 2 squared plus a negative 3 squared plus 1 squared. 4, 9, and 1. So around 0.53. Okay. Now the point. So how do we do that? So the point, now we've got A and B, and here's P. So P is X, Y, Z. B was 002, and A was 111. We know this vector, AB. We know this vector, AP. And we need that point. So what do we do? Yeah, these two, to get that, right? I think now that I'm seeing this, I think on the homework I made it more complicated, of course, which I did, found this vector between them and then used those two, but of course you don't need to do that. We know A and we know P, so, and we know AP. So AP is the vector between P and A. And we have A, so of course I shouldn't have made it so complicated. P minus A. 2/7 plus 1. 4/7. 8/7. Now remember, that's a point. It's not a vector. You don't want to factor out the over 7. You don't factor things out of a point. Right? The point needs to be the point. Right? So you wouldn't have fluked into this point. Right? Remember I said sometimes when you find the point on the plane, you find the right one right when you start. But of course, if it's a fraction, you're not going to have these numbers as your starting point. So. Okay, so we're not going to get to 1.5, which is a short section, but I was, actually, I have one tiny little thing, and I don't even have an example for it, just a note to end 1.4. So let's write that note, and then we have 1.5 left to do next class. So the last thing in 1.4 is, actually it is an example, but it's quick. So the projection, so let's say find the projection of Q onto the plane spanned by and it really is just a tiny little question, because I just wanted to point out. So the plane isn't given in the other form, and we're just asked for a projection of this onto this plane. So our plane is here, and say we have this vector Q. We want to project that down somewhere in the span, which is just the whole plane of these two. So how we do that is that you don't need to go and find the complicated way would be to find the standard form of the plane, get the normal, project onto the normal, and then subtract them. So you don't need to do any of that. It turns out that the projection of any vector onto a plane, that you know some vectors in the plane, is the projection of Q onto one of the vectors plus the projection of Q onto the other vector. So we don't even need to do the question, you would just do the dot products of them. It's like two different questions. So this answer, if you wanted to project Q onto the plane, the plane spanned by these, you just find them separate and do it together and put it together. So this would be U dot Q and the question in the book that I assigned ask for a linear combination. So once you find the answer, you just write it out like that with your numbers. So if we just did this, U dot Q, 2 plus 3 is 5 over U dot U, 4, 5, 6. 1 and 9 is 10 over V dot V is 9, 14. And then you could actually find the answer. So this is a linear combination. But to find the answer, you would just work that all out and get one vector. Okay. And multiply the 5, 6 in, so on. Okay, so that's the end of 1.4. I will post the questions for the practice for that and the answers, and then we'll finish 1.5 next class, and then I'll give you the test to take home.